On, off, low, high, low, modulating. Turn down ratio 2 to 1, 5 to 1, 10 to 1. What do I choose?
Choosing a new boiler burner is so confusing, almost like you need 2 degrees and a shaman to make the choice. The old boiler was simple. There was a pilot light, and when the thermostat called for heat, whoosh, the flame came on and heated the building. Did that for 30 years. Now you have to choose between firing rates and burner turn-down ratios. It's so confusing. Relax. I gotcha. This is Boiler Room Detective, and I'm your host, Ray Wolfarth. Gas burners come in 2 styles, atmospheric and power. The atmospheric burner has a quicker response because it does not have the pre- and post-purge on the firing cycle like the power burners do. The drawback is that they are less efficient than a power burner. The advantage is they have lower maintenance than a power burner. The operation of an atmospheric burner is simple in design. It injects gas through an orifice into the burner, increasing the velocity of the fuel. The increased velocity initiates a Venturi effect and pulls the primary air into the burner where it's mixed. Secondary air is supplied around the flame. There are no moving parts. The power burner uses a blower to mix the air and fuel to get better efficiency. On a call for heat, the blower starts. The blower runs long enough to produce 4 air changes in the boiler. This assures that any leftover combustible gas is removed from the boiler and breaching before the spark is ignited. This is called pre-purge. The pre-purge time on a power burner is typically 30 seconds to 2 minutes. Once the pre-purge is complete, the gas valve opens and allows gas to mix with the air. The first choice you're going to be asked is an on-off burner. When there is a call for heat, the burner starts and it operates at full fire or 100% until the call for heat ends. The drawbacks to this on-off burner is that it cycles frequently during light load times, and it has a louder ignition. An on-off burner is usually the least expensive type of power burner. The next is low-high off. The burner starts at low fire for smoother ignition, and once the flame is established, will travel to high fire and stay there until the call for heat has ended. The third one is low-high-low, and you'll see that as LHL. This burner starts at low fire, and when the flame is established, will travel to high fire. It will stay at high fire until it reaches a set point on the firing rate control. At that point, the burner drops to low fire until the call for heat ends, or the temperature or pressure at the sensing point of the firing rate control drops low enough to drive it to high fire again. The firing rate control is usually set at a lower set point than the operating control and limit control. For example, the firing rate control on a typical hydronic boiler will be set at 175 degrees. The operating control is set at 180 degrees, and the manual reset set around 200 or 210 degrees Fahrenheit. The modulating burner. This burner will start at low fire and then travel to high fire until it reaches a firing rate control set point. At that set point, it will vary the firing rate anywhere from high fire to low fire, depending on the signal from the firing rate control. This is a multi-position burner. Okay, what is turned on? If you're like me, it's what happened when you asked your kids to clean their rooms. When it pertains to burners, it's quite different. Burner turned on is a percentage of the high fire rate that the burner can safely reduce to. The lowest firing point is called low fire. Let us assume we are going to purchase a 1,000,000 BTU boiler, and the representative has 3 of the following options. Boiler 1 has a 2 to 1 turn down, Boiler 2 has a 5 to 1 turn down, and Boiler 3 has a 10 to 1 turn down. What does that mean? Boiler 1 has a 2 to 1 turn down. That means that the boiler can reduce firing rate to 500,000 BTU. Boiler 2 has a 5 to 1 turn down. It means that the burner can reduce the firing rate to 200,000 BTU. Boiler 3 with a 10 to 1 turn down means the burner can reduce the firing rate to 100,000 BTU. The higher the turn on, the less the boiler cycles. This helps when you need a consistent temperature or pressure in the boiler. The firing rate of the burner is controlled by either the firing rate control or the modulating control. How does cycling affect boiler efficiency? When the boiler restarts, the burner goes through the pre-purge where it blows cooler boiler room air through the boiler and up the stack. This pulls heat from the boiler. If you find this video helpful, please like, subscribe, and share. My boiler books are available at Pronto Heating Supplies, T.F. Campbell, and Amazon. If you have a boiler issue, email me and we can try and find a solution together. This is Ray Wolfart, and I will see you on the next case.